Mr. Kenny,
Yes, ma'am.
I forgot how to do like this.
Ask the question yourself. Thank you. Thank you. Okay, which of these questions are giving us fits to the point where we're like, I got no clue? Look at part 3 a little bit. I assumed we should look at part 3. At least one question at part 3. Part 4 a little bit. Okay. So we'll look at a little bit of part 3 and part 4. Michaela, was your question from part 3 or part 4? Michaela? Was your question from part 3 or part 4? Was it something else?
Never mind.
I can't help you if you don't ask your question.
Yeah, never mind.
Okay. So let's look at part 3 and part 4. Just as a quick heads up, I mentioned this earlier, I don't know if you heard it. I am going to send out a set of solutions for this practice. In fact, I'll send out an email just saying I've posted solutions. If you go to Schoology, I have a section within Schoology under Unit 1. If you click inside that folder, it will show you what there's a folder for solutions. I'll send that in an email, and I will post solutions for every understanding check. And I'm going to try to fill out the graphic organizers a little bit to help you, and something else, and just practice assessments like this or practice problems like this, so that you have that to study with. But let's look at parts 3 and 4. I will say this. Let's look at number 1 just briefly. This one won't take long. A equals 1/2 B H. What does it ask us to solve for?
H.
H. That's it. Okay? And so we just need to notice that H is being what?
Multiplied.
So how am I going to undo that?
Division.
There's an easier way, but yes.
1 over H.
No, I'm trying to solve for H. I want H on its own. Right? So what do I need to do? Yes, I can divide, but do you want to divide by 1/2? No, we don't. Thanks, guys. So what can I do to undo this 1/2, or 1 divided by 2? Huh?
0.5.
Yes. Yes. Listen to the question again. What can I do to undo 1 divided by 2?
Simplify.
Multiply. The inverse of division is what?
I just said multiply, Mr. Kim.
Yeah, you said multiply by 1/2.
Oh, I was gonna say
2/2.
No, not 2/2. By 2.
But then we do that, you say we need to multiply by a fraction.
I never said you need to multiply by a fraction. I said you need to multiply by the reciprocal, which is where you switch the numerator and denominator.
So why you want to do 2 over 1?
it's that way.
Because that is the same thing.
Alright, that's how I like it like
Okay. I'm glad that makes you happier. So notice 2a is equal to bh. Now you could have done these 2 steps at the same time, but notice you're thinking about a fraction because this b is understood to be divided by a 1. So instead of dividing by b, what do I usually do? I multiply by its
that. 1 over B.
1 divided by b. Remember that multiplicative inverse is the reciprocal. And so 2a divided by b is equal to h. If you, where?
You went too fast.
Hey.
Where? There's 2
I just got a
steps.
quick question. When have we ever went over there?
On Matthew.
One,
I'm just asking seriously.
I know you're asking seriously. One, I don't remember the exact lesson, but we did it in one lesson. Oh, we did a lot with bell ringers.
Okay.
We did a lot with bell ringers, so we should have notes on it there. And there were 2 whole workspaces on Matthew that were devoted to literal equations where there's multiple variables involved. If you are struggling with this, one, you may need to go finish those Matthew solving equations. If you're still struggling with it, you may need to go back to the 2 workspaces on literal equations. That's what they're called. Okay? There's a lot of practice problems there, but we did it a lot with bell ringers. Because we spent about a week and a half just doing these in bell ringers.
So on number 2, we got to solve for B1.
Yeah.
We gonna do number 2?
Yes, that's the more complicated one.
Okay. Let me do it first.
This one's a little bit more complicated because there's multiple things happening here that you would need to take care of. If you remember the foundational idea that we want to work with whatever is furthest away from the variable first, that will help you significantly here. Because what's the first operation happening to B1?
One divided by 2.
Nope. It's being added. It's inside of parentheses. Don't you have to add what's inside of parentheses first? So it's being added first. And so like we need to recognize the last thing we're going to do is take care of this addition. Then it's being multiplied by 1/2, or you could even say it's being multiplied by h. Those would happen at the same exact time. You got to recognize the order of operations, and an important idea is that when you solve an equation, it's basically like you doing the inverse of the order of operations. So what do you want to do first?
The reciprocal of 1/2, so
Which
do
is?
2 over 1,
2,
divided by 1.
there we go, that works.
And then A2,
Well,
and 2A
2a,
equals B1 plus B2 times 8.
make sure you keep your symbols bringing down. A
Then
lot of us forget our parentheses or forget our negatives, and that hurts you significantly. Or on the vertex form, on the understanding check, we forgot the square. Hurts you significantly.
Then you do 1 over H, 1 divided by H.
There we go, 1 divided by h.
Times 1, yeah. And then that'll be 2A over H.
Don't forget, in case this is where I lost some of you last time, 2a is understood to be divided by 1, and when you multiply fractions, you multiply numerator and you multiply denominator.
And that's H right there.
And so I'm going to rewrite this over here, so 2a,
over 8 divided by H
thank you,
equals 1B plus 2B.
b1 plus b2.
Yeah.
The difference is if you say 1b and 2b, you're talking about a coefficient,
Oh, yeah.
not a subscript. It's
Right.
1 and 2 because it's indicating the two different bases.
Mm-hmm.
Now I'm going to pause before Anthony jumps on ahead. Chicalo, are you working on this problem?
Hmm?
Are you working on this problem?
No,
Well, that's why you got confused earlier.
my bad.
Trying to do multiple things at once.
Yeah, my bad.
Stop trying to do multiple things at once, guys. Multitasking does not work out well.
Now this the easy part now.
It is the easiest part. At this point, he's not saying the whole thing, he's saying this part. Michaela, does it make sense now? Because I know you were saying I was going too fast
No, it
earlier.
don't make sense.
What doesn't make sense?
None of it. Like, you moving too fast. Like, I don't know how you, at first, like, I get the little 2, like, you divide, but, like, why you dividing by 2A?
I'm not
I
dividing
mean,
by 2.
multiplying by 2A.
Are you talking about this part here?
No, like, the first part.
Well, if I multiply one side of the equation by 2, just keep it equivalent, I gotta multiply the other side of the equation by 2, right? So Michaela, do you understand why I multiplied by 2 on the right-hand side?
Yeah,
Huh?
yeah.
So then if I do it here, I gotta do it here. If I don't, I'm not making an equivalent equation. That's just the properties of equality. Dawson, what's my last step gonna be?
Divide.
What am I gonna divide by?
2A on both sides.
Huh?
2A on both sides?
Okay, that's what I was wondering. So remember, what am I solving for? You gotta keep in mind what I'm solving for.
8.
Am I? In this one?
Or 8.
Am I?
Oh,
Look at the directions. Solve the equation for B1. I'm on number 2, Dawson. I'm solving for this.
Oh, I was right in the wrong spot.
Dang.
What's happening to B1 that I need to undo?
Addition.
So what do I need to do?
Subtract.
By?
B1.
Remember, I'm solving for B1. I'm trying to get rid of everything around that B1.
2.
B2. Because what is B2 minus B2?
0.
0. Just like I was making ones earlier, right? I'm making a 0 now because there was addition, and the additive identity is at 0, so I had to subtract to create that. Now, these are different terms, so I cannot combine them. There we go. That is, I'll go ahead and tell you, more complicated than what we will see on the test. But you may see things like number 1 or number 3, or something like part 2 on the test. They're just literal equations. You're using the additive and multiplicative identities to solve for a specified variable.
What you finna do next?
Huh?
What you gonna do next?
Well, someone asked about part 4.
Can you do part 2? Your one on? Cause I forgot.
Oh.
So serious.
I'll come answer it when we're working on something else later.
Alright.
We got other stuff we gotta work on. For those who asked about part 4, who wants to tell me one to look at? We're just gonna look at one for now.
I used to do the reciprocal of positive.
Do two.
Oh,
Pi is understood to be divided by 1, isn't it?
yeah,
There you go.
okay.
Number 2. Wait, we literally did number 2 for the bell ringer. Give me a different one. 6, cool. That's actually a very good one to look at. 16x squared minus 10 is equal to 15. A lot of people are going to freak out because you got 16, a 10, and 15. But like, remember, start with the basic principle. The first thing happening to x is that it's being what? Squared. After it's being squared.
What's about
5.
16?
And then after we multiply by 16, minus 10. That's the last thing being done. So that's the first thing I'm going to do. Undo. Inverse is subtracting by 10.
Add by
Adding by 10. Notice that's going to create what number?
0.
Is there anything else I need to do?
Add on the other side.
Remember, I don't want to change the identity of this equation. I want an equivalent equation.
You don't stop there, do it.
Oh, you doing 6.
Have I solved for? Yeah, I'm on 6.
Oh,
Sorry.
you gonna keep going? Okay.
I was saying I haven't solved for x yet, but like, what's happening to the x right now? It's being squared and then multiplied by 16.
16x squared is just 4. 4
You're thinking of the square root.
So you don't do that with
First off, that square
Mhm.
is not on the 16. It's just x squared.
Man, you do,
One.
1
I could divide
over
by
16,
16 or multiply
1 over 16,
1.
divided by 16.
Remember, I want you to think about that multiplicative inverse to create that multiplicative identity. Just because it's got a bigger number, Anna, that's a good question, but just because it's a bigger number doesn't change that. If we're multiplying, I need the inverse of that. Does that make sense? Notice, what is 16 divided by 16?
0.
1.
We need to start using those calculators, fam. I cannot emphasize that enough. Stop thinking that it's cool to do it in your head. Use a calculator. Just check yourself. I don't care about your ability to calculate. I care about your ability to accurately solve an equation. We got calculators, use them. So 1x squared is equal to?
25 over 16.
Thank you, sir.
Dang.
Again, can you just use a calculator to multiply these?
Yeah, you can.
You can, right? So like, don't be freaked out by a fraction. These calculators are beautiful because they do fractions for you. They even simplify them for you. Last step, right? I've only got one more step to finish solving for x.
Square root.
Square root. Can your calculator do the square root of 25 divided by 16?
Yeah,
Heck yeah.
5 over 4. 5 divided by 4.
5 divided by 4, 5/4.
Okay.
Am I done?
No, it's a negative one too.
When I take that square root, you have got to remember it's a positive and a negative. If you're forgetting that, you need to go to the Solving Quadratics workspace on Mathia to practice that. Yes, ma'am.
I still got the same answer when I did when I told you I got 4.
Yeah, you got lucky.
How?
What did you? So, when you were here, what did you do?
I just square root 16 and it gave me 4x squared, and I just put 4 and picked the.
So you just square rooted the 16 and got
Yeah.
4?
Yeah, and then I brought down x squared equals 25, and then I did, and I erased it.
Yeah, you got lucky then. What you could have done, Jakayla, is you could have taken the square root of all of this at the same time,
No, yeah,
and then that would have given you, but here's the complexity, anytime you take a square root, technically it's a plus or minus, and then it would have been a plus or minus 5. What are you gonna do now?
no, I didn't do that.
I know, that's why I said you got lucky,
Erase it, too?
okay? As I said, I will send out solutions showing work and where we're paying attention to the inverses and the identities all the way through. Justifying our answers. Don't forget you have a whole understanding check on this. But I want to look at the understanding check that we had yesterday briefly. First things first. I told y'all straight up and down, you have to know these equations. Did I not?
Yes, sir, you did.
It was disturbing how many people did not get a 6 on this number 1. It was disturbing how many of us did not get a 6 on this number 1.
You got a 6 count?
I got a 5.
Dang.
I know, several of us did get 6s. All that a 6 was meant that you wrote all 3 of the equations down correctly and you identified what the form was.
Yeah.
How about all I need was my equal sign?
Kind of important though, isn't it?
Yeah. That's really the only thing that's missing.
You gotta know your equations. There are lots of resources that we've used to help you study them. Go back and look. Here's numbers 2 through 4. You already have the solutions written down. If you did not know which features went with which equation, and notice how I identify my A, my R1, my R2, my H, and my K. But if you didn't know which features went with which equations, you need to write down M1-73 to M1-75. Those were the graphic organizers in the textbook where we wrote down those details. If your details in the graphic organizer are wrong, there are videos online that you might need to go check out. M1-73 to M1-75. Man, I see like 3 people writing this down, even though only like 3 of us got all of these right. Tell me how that makes sense. Mr. Kenny, I don't want to be successful. I'll ignore everything you say.
I understand it now, I just messed up on my, y-intercept. Cause I thought Vertex showed me the y-intercept, but standard.
Yeah, I'm starting to understand a lot so late. By the time they take on,
The vertex shows the vertex.
Yeah.
And then the axis of symmetry. Remember, every single one shows a different feature. Every single one. They all show concavity, but each one other than that shows a different feature. But they each have another feature. Y-intercept for standard, x-intercepts for factored form, vertex and axis symmetry for that vertex form. But M1-73 to M1-75, that's another thing where you could create a note card or a Quizlet or something where you write down the name of the form and you write on the back which features that equation shows. And correctly write it out, because I saw a lot of people here on the x-intercepts doing 0, R1 and 0, R2, when we should know an x-intercept has a y value of 0. Which point has an x value of 0? Thank you. One is engaged there. Bless you.
Wait, Mr. Kenny, you ain't got the same thing we got.
What?
You gotta look for it.
What are you talking about? Oh, I rearranged the test, or the understanding check, because I made it the calculator and non-calculator portions. The questions are all the same. I just switched the top or the bottom of your front.
With the
And my
back of
bottom.
that, yeah.
So just a couple more minutes talking about this one. Y'all, in number 7, I think everyone or most people talked about concavity. Is concavity the only feature seen in an equation?
Huh?
Is concavity the only feature shown in an equation? No. So should you have only talked about concavity?
No, sir.
You got to talk about concavity, sure, because the concavity works for A and B. It doesn't work for C. But each form shows something different. I saw a lot of people here on A saying, hey, there's 2 x-intercepts. Guys, most of the time there's 2 x-intercepts. What's important about these x-intercepts? They're both
Negative.
negative.
I said that too.
Are these x-intercepts negative?
Yep.
Yep. That's why it can work, because the x-intercepts are both negative and it's concave down. If you check B though, the vertex was 5, -3. 5, -3 would be to the right and down. Does that match this vertex? So is that a possibility? Nope.
That's the maximum point right there.
It is the maximum because it's concave down, yes. But then C was concave up. The y-intercept was a possibility, but because that was concave up, it was not a possibility.
What they did right there for you, a grade for you, see?
Notice all the way through I identified the different features. I made a note, hey, both roots are negative, so that works. I said it's concave down based on this piece right here. And so I have told you why this one is possible. I made a claim, I have evidence all the way through.
Miss Kenny, why they couldn't get a 6 right here? And I explained everything. Everything.
Just because you explained everything doesn't mean you correctly explained everything.
Oh.
So like was there a C next to any of those numbers, those scores?
I just got 5 on. It's a grade. Would you get A? Would you get A? Where? How?
Where did you get A? How did you get A? Which, so you got, I mean, a 5.5 is near perfect. I just need you to tell me how you got that A value. Which you got it from the vertex form. This we've worked on a lot. You have a whole set of practice problems. I will send out solutions for practice problems like this. But again, if you don't know your different forms, this was next to impossible to do. You got to know the 3 different forms of quadratic functions. Please make a note on number 8. What form were you given to start on number 8? Did you do all these perfectly? Come on, man. You got your understanding correct.
You give us a quadratic form.
You're given a quadratic function. What form is it? I asked you for factored form. It's in vertex form.
I did both.
So write down. Oh, you didn't get an understanding check at all?
Yeah,
Why aren't you telling me this, 15 minutes ago? You remember where the extras for the understanding check went yesterday?
Right.
Thank you. So, does the vertex form, well, what do you need to write factored form?
You need both of the x-intercepts.
You need the x-intercepts or the roots, right? Does the vertex form give you those roots? No, but you're on a calculator portion of the understanding check. So what could you do to get those roots? You could graph it. Right?
But I mean, you really ain't got a graph it because the graph right there.
That's number 9.
Come on, dog.
And that's a -4 and a -2. That just happened to be similar, not the same at all.
So this was a whole different problem.
Yes. That's why it says 8 and 9.
Bro. I still got it right though.
Yeah. I think you forgot that it was 2 different problems. You definitely worked it as 2 different problems yesterday. Alright. But we got to recognize our equations. If you get vertex form, you're going to see the vertex in that equation. You're not going to see the roots. In order to see the roots then, just graph it. Make sure you make a note of this, that you can graph it. Now, do you need to do a whole bunch of extra work to get what A is?
Yes.
For number 8?
No.
Yes, you do.
Hey, nigga.
You already knew A because I gave you vertex form. That A is -2. That's not going to change. Some of us did do a little extra work, didn't we, Sharnadia? Were you the one that did all that extra work for number 8? Where you worked out to get what A was? But you're already given what A is on number 8.
So what could have explanation could I told you that how I got?
A is equal to -2.
That's all I had to say to get a C.
And notice how I showed it in the vertex form? And I showed how I got A equals -2? You got a 5.5. That's near perfect.
I need a C.
Alright. Last thing before we move to the last thing for today. Did you have to do factored form like I did?
And you could have did vertex for number 9.
Number 9, you could have done the vertex form. Whichever form you did though, you need to be careful about how you're substituting in. And guys, I cannot say this enough. You need to be careful about writing your points. I cannot tell you how many times I saw 0, 2. Is that x value 0?
No.
Nope, that x value is 2. The x value comes first. What's the y value?
0.
You gotta be careful about
You
that.
wrote that in,
Hey, stop.
No, what?
Also, we need to be careful because I saw someone here do 0, 5. That's close to 5, but 5 is right here. So is that exactly 0, 5?
Well, they're like 5.5.
5.3, I don't know exactly what it is, but it's definitely not 5. Use a clear point, a point that is on an intersection of the grid.
Now that I think about it, after you said something, you probably did it.
No.
Oh, okay.
Alright, we need some more practice though, not just going over to the understanding check. You have a copy of this understanding check with my solutions so that you can learn from your mistakes. I try to give you some feedback, however, we're not completely there. Continue to work. You may not have done as well as you're capable of. Actually, I would say none of us did as well as we're capable of, which is why I will use the test to reassess your skills. If you need to, you know you're struggling with one part of this, there's videos on YouTube. I'll be here Monday morning for tutoring. Come on in and I'll be here to help you. Send me an email. I can send you some other resources. But we gotta learn as much as possible before our test. Now, I need you to have 6.6. How does it grow out? We started to look at that yesterday.
Mr. King,
Sir,
I need a copy.
we're not here last Wednesday either?
He was out. I think he was out.
Alright. Please note, we talked about the definition of relation versus function yesterday. Use that today. I would heavily focus on differentiating linear, exponential, and quadratic functions, and I would work on writing those equations. Those are the main things to keep track of. Now, every one of these I would try to write an equation. Work as efficiently as possible to get through as many ideas as possible, and ask questions when you get confused, but we need to work efficiently for the next 25 minutes to help each other. I think it's 25, a little less than 25 minutes, to grow as much as possible on identifying linear, exponential, and quadratic functions before we have our test on Monday. Are there any questions about what we're doing with this task? Say which part. We're using this to identify linear, exponential, and quadratic functions in multitude of representations, and you need to be ready to write equations for linear, exponential, and quadratic functions. Okay? One quick note, this will help you. I do want everyone to look at this number 7 really quickly. It is not given to you, but this will help if you're trying to write this equation. Anybody know what the stop, if like you're going 0 miles per hour, how many feet is it going to take you to stop? 0. I want you to note that might be the minimum. Might be able to write an equation if you know that that's the minimum. But I'll be coming around so you can ask questions, you can help each other grow and learn. But let's get to work. And then, Kyla, you had a question, Michaela, you had a question. So I'll start there. Anthony, you've been doing well. Get your head up, let's get to work. That's just number 7. There's a second page to this. Let's go to the second page.